All right, I think we are live. Hey everyone, thank you so much for joining this month's Community Sync. We'll give it a couple minutes before we start our session. We have an interesting presentation today, and yeah, we'll be sharing some community stats as well. So yeah, we'll give it a couple minutes and then we'll get started. Let us know where you're joining from, and how you're implementing Hoodie, lake houses, or and all right, we see people joining in. All right. Yeah, for people who are joining now, so we'll be getting started with the session in a couple minutes. We have some interesting presentation today. We also have community announcements that happened in the past month. So in a minute or so, we'll get started and yeah, get through those numbers. Let us know where you're joining from and how you're implementing lake houses at your organization, how you're using Hoodie, any questions around that as well. All right. I think we're good to get started now. So, welcome everyone to the Hoodie Community Sync for the July month. If you're new here, the Community Sync allows community users and developers, contributors to meet, interact, and exchange ideas on Apache Hoodie, and how it is implemented in various organizations. And that's a really good way to understand like some of the lessons learned, the pain points, what has worked, what has not. So we try to bring this, presentations to the community, and it's a really good learning experience as well. So today we have yet another amazing presentation from Metica Engineering. Metica is a B2B SaaS product company that helps in personalizing gaming experience in every form. And during this presentation, our speaker, whom I will introduce in a few minutes, will discuss Metica's data platform journey and why and how they choose Hoodie right from the very beginning phase to how they're leveraging advanced capabilities now with Hoodie. Before we go into the actual presentation, I'll be going over some quick community stats and updates, and then we'll start our session for Medica's data platform, and then we'll end with a quick Q&A session. So since the session is live on LinkedIn, feel free to post your questions in the chat as well. And as we go through the session, feel free to put it out there, and we will take these questions, and our presenter will help answer those questions. All right, so let's jump into the community stats. So in the last month, we have had over 100 PRs, and yeah, a lot has been brewing on the Hoodie project side. We have had two major releases until now. So point 15, which brought in things like new storage and IO abstractions. On the compute engine side, we have had Spark 3.5 with Scala 2.13, Fling 1.18 support as part of the point 15 release. We also have a new Hoodie native H file reader, which allows like engines like Trinos to take benefit of it and not rely on Hadoop dependencies. So that's really amazing. On the Hoodie 1.0 side, we have a beta 2 release now, and this release comes after 7 months after the beta 1 of 1.0. And this is a complete new direction for Hoodie as well. It gives us a kind of a new direction in terms of like applying like a lot of other things like secondary indexes that we have now, partition stats index, positional merge with like filter push down like things. So really interesting features. We also recently added lookup joins with Hoodie Fling. So those are the kind of things that's going on. And you can read more about these releases on the release notes on our Hoodie sites under the downloads section of the blog. We have had 44 developers who contributed to these PRs. We also closed 26 issues during this period, and there are new PRs that are being worked on now. In terms of the community growth numbers, we have had over 4,300 users on Slack today. So Slack is a really great place for Hoodie users to bring up any discussions. issues while implementing Hoodie. There are PMC members as well to chat one-on-one. And I'll share the link in the next slide for you to join. So, feel free to join the channel. On GitHub, we have had over 5,200 stars, so really good momentum in general. And of course, I mentioned about the major releases at the contribution side. Also, we are super excited to announce the release of Hudi RS, which is a complete new direction. It's a native Rust library for Apache Hudi, now with bindings to Python. And with this Hudi RS project, now we can use Hudi for a diverse range of use cases in the Rust and the Python ecosystems now. So this new way is kind of like a way to like go beyond Spark and JVM and not being dependent on those things. And it's a new way to like use new Python-based data frame libraries like Polars, DuckDB, like DAF, whatever it is. So please check out the GitHub repo. I've just put it out there, and if you're looking to get involved in any form, it's really a good phase of the project. We are looking for community members to get involved, and share like start a PR. Reach out to me in case you're looking forward to like taking some of the PR already. So the community is really growing and in all aspects. If you haven't already, give us a follow on LinkedIn and Twitter. We share a lot of contents over there, a lot of good examples of how people are implementing Hudi. You can also start us at GitHub if you are using Hudi, and the Slack channel link is over here. You can just scan the QR code to join the channel. So with that, let's welcome Subash. Subash is the data ML lead at Metica Engineering, and he's going to like walk us through all these things. Subash, take it over from here.
Yeah, sure. Cool. Thanks a lot, Dipankar, for the introduction. And a good day to everyone, whether it's morning, afternoon, or evening in your part of the world. So it's really great to be here to share our journey with Apache Hudi and how we used a few of the features as we grew as a company at Metica. Quickly on the agenda, I'll be talking about introduction, about me, about the company, and talking about the high-level architecture and where Apache Hudi fits in. And also, we'll have a sort of a deep dive into what kind of features we used in what timeline when we grew as a company, and also a few learnings that we got from it. And obviously, we'll finish it off with the question and answers. Yeah, quickly about the introduction. About me, myself, Subash Prapanantham. I'm originally from India, as you guys can see and hear. Right now, I'm based in UK, London, and currently working at Metica, as Dipankar said, as a ML engineer and data engineer. Prior to this, I was working at PayPal, Visa, and Apple. So Apple was our previous employer, where I met my current founders and teammates. So we are basically ex-Apple employees who spun out and created this startup. So I have total of somewhere around 10 years of experience in the data space. So starting from working in data platforms and also in data products, predominantly in the fintech and marketing space. So hence you see segmentation platform, experimentation and data quality frameworks and platforms. This is me. And about our team. So we are a very small team. We are a 30-member team right now, including the founders. And collectively, we have total of 14 plus years of experience, specifically in the gaming industry. And as I said earlier, we are all ex-Apple employees. And prior to Apple, a couple of folks in the team have worked in King as well. Hence, you see our particular use case currently solving is also a particular problem in a gaming industry. So for folks who don't know what King is, so they are the ones who created Candy Crush, quite a popular game. And these guys were there when that was happening as well. And our company is currently VC backed, and Play Ventures for Spinnet Capital or few VCs backers. And we do also have a couple of early adopters. Right now, we are in a phase where, as any startup at this stage, we are finding product market fit, as well as we are growing the business through potential clients, starting from small to medium to large companies. Quickly about what do we do? So Metica platform in one line, as Dipankar said, it's more like a B2B SaaS product. We believe and we primarily focus on personalizing every gaming experiences. And how do we do that is based on the experience these folks have in the gaming industry. So we have developed some cool ML techniques to provide adaptive offers, intelligent bundles, and contextual optimization working together as an integrated product suite to help the game developers and game studios to personalize for every players, which would thereby increase the LTV of a particular player, which increases the revenue. So that's the idea behind it. And quickly, let me go into the architecture. So before going into the architecture, we wanted to provide a sort of an background of why we chose Apache Hudi, right? So when we started with solving this problem of, right, so we uh, want to have a data platform where it scales over time as we have more features added into the platform. As a company, what we believe in is like we wanted to have technologies which are open source and also backed by the community, not like an one-off thing where an open source which is cool but not backed by the community. That is one thing. Another thing is, since I mentioned earlier, we are a very small team, a 13-member team. We don't have the luxury to basically keep changing the technologies over time as we grow as a company as well. So our main focus was, as we grow as a team, as our data grows, and also at a very uneven time scale, because as most of you folks know as well, a startup would have client of different sizes comes in a different time. So we wanted to have a data platform which is stable and scalable enough. When you have bigger clients, it's not a bigger change that we want to make in our architecture. And another reason behind using Apache Hudi or any of a table lakehouse format is to support different query engines. So the things which we have seen so far is like, which I'll go through also in the architecture, is having a multiple copies of data is something which we wanted to avoid. And having a query engine which reads on top of the underlying lakehouse data set is really, really important for us as well. And obviously, which offers a easier maintenance as a whole, as a platform and also a data format. And quickly about the high level design. So our architecture and our engineering stack is hosted in AWS. So AWS is our cloud provider. Hence, you see there are products from AWS. So people who are from AWS are quite aware of these products. So what we have planned is like, we needed a cost efficient architecture, and also we needed a components separated and independent in such a way that they are scalable on its own. So what I mean by that is, we have a separate compute engine. We view it as like a compute engine. We have a catalog and we have a data storage and we have a query engine. And each of those components scales independently. That's the idea behind it. So as you see here, so what we have is primarily we have the events coming through Kinesis, and we journal those events into S3 as a raw events, as a JSON format. And then we create those transformed events, which is again in a Parquet format, and we do minimal cleaning and transformation. And finally, the data products, so which we call like all the like gold data sets, which comes from the data products, as well as some aggregates that we create, are stored in Apache Hudi format. And this architecture, I mean, this is a very well known architecture. It's a medallion architecture. It shouldn't be a big surprise for any modern architectures there in our data platform. The other thing what I have to point out here is the query engine we use currently is the Seller Data. If for people who don't know what Seller Data is, Seller Data is a managed solution, provides a managed solution for Star Rocks. The reason behind having this query engine layer is obviously, as I said earlier, prior to this, I mean, in my past experience, the way we did an architecture was, you have a data warehouse in some places where you have an integrated product like a Snowflake or a Teradata, to be more traditional, right? So in that scenario, having a data lake, which is of Parquet format, and then moving the data into a data warehouse is an hop or a data copy. And then there are query engines and clients on top of it, which queries those data sets. Sometimes we find a lag between this transfer, or also to have a data freshness. It's not an intelligent solution to move the data here and there. So hence we were looking for a solution where once we store it in the lakehouse format, how can we read this without doing a copy? So that's where we were looking at few query engines, and Selenita, which is StarRocks, helped us a lot for our use case. Our use case is more towards having a sub-second latency while querying. And we did set of benchmarks, and this worked very well for us. And again, as a catalog, we currently use Hudi, we use the AWS Glue data catalog. And as a compute engines, we use Spark and Spark Streaming. And EMR is our Hadoop cluster. And eventually, one thing which I want to point out here is the reason why we went ahead with having JSON and Parquet as a bronze and silver formats is to have the flexibility at the early stage as our company. So as we grow, our plan is to basically use the table formats in those areas as well. But before that, we want to do testing with the gold standard products, like in the scenario, Apache Hudi in the gold tables, which work pretty well for us. And we are a little confident right now to use the same sort of a table format everywhere in the ecosystem. And quickly moving on to how we use Apache Hudi at Metica. Yeah, so this, I want to provide a different view of how we were actually planning to use Lakehouse format. First and foremost, before we started off this journey of building a data platform, this is our first use case of using a data lakehouse in a data platform. So prior to this, we were predominantly using Parquet as a primary format, and we used to do a lot of features that Hudi provides in-house. So which I'll go in depth in the next slide. So the idea is we first went ahead and then created this sort of a table saying for each of those features or a top level features, what is the nature of data that we will have and what is the operation that we will perform on those data sets. Just for an example, if you take experimentation as a use case, we do have a very fine-grained data set there. So that is more like at a user level data set and sometimes at an event level data set as well, which is broken down by multiple dimensions, right? And those are, if you look at it at a table level, it's a very huge data set and it's quite mutable in nature. So what I mean by mutable is the operation that we do day to day or in a daily basis in a pipeline is doing a lot of deletes, doing a lot of updates at a record level. So hence, Hudi plays a big role in having this data set represented as a Hudi table format. Whereas for the data ingestion, this is quite immutable in nature because as I showed in the architecture, we don't have any transformation layer. It's just like write and then forget. So at that point, we do a lot of overwrite of the partition. So there is no need for a mutability there. So it's just write. So for these kinds of use cases, we haven't yet explored using the data lakehouse. Whereas the reporting and ad hoc analysis, again, we have a lot of mutable data sets in those areas as well. Particularly, this is quite different than the experimentation data set. The reason being, just for an example, if you take the ad hoc analysis, the way it works is like there are some writers which keeps writing into the particular table, whereas data analysts or data scientists would read that table at the same time. So hence we needed an isolation on these operations, right? So typically when we worked with purely with the Parquet files, the problem I think most of us would have faced is like when a particular writer writes the Parquet file, and the reader is also reading at the same time, the Parquet files changes after the write. So this is a common issue that we used to have. To create the isolation, we had different patterns, like having a partition by date or timestamp and things like that. But Hudi gives us those flexibility in-house. We didn't want to do those ad hoc or bespoke implementation to achieve that. That is one other thing. And to point out another direction of this is like for the data ingestion specifically, the reason why we have immutable at this point is we don't have any incremental processing in our pipeline yet. So the idea is when you have an incremental processing sort of an architecture, we didn't want to change much of our design choices. As I said earlier, as a startup, when we grew, we don't want to migrate many technologies as we grow. So this was a very conscious decision that we made when we go to incremental processing as a complete pipeline execution. It shouldn't be a big change. And having a Hudi on the gold datasets and potentially silver dataset and bronze can also be changed into Hudi and enhance the incremental processing without any changes on the complete architecture. So quickly on the Hudi platform features. So this view is a quite interesting and a good view to show as we grew as a company. I mean, startup of our size, I mean, at any stages, we do get clients in different time scales. So hence we have challenges over time. This view is pretty good to show how Hudi helped us to solve some of the challenges we faced over time, specifically in the data landscape. Uh, to just quickly go through that, one is first we started off with copy on write, as everyone knows about it, because most of our use cases were not very heavy on write, and the data sets initially when we started off, like somewhere around August 2023, was very small in size. So we didn't find a big difference of using merge on read versus copy on write. And copy on write was quite easy to use and play around with as well. So hence we started off with copy on write. And eventually we moved on to merge on read. So merge on read use case came in when we started having more real-time use cases, specifically on the reporting landscape, where when we had more user-level data set has to be updated, copy on write, as every one of you guys know, like it just copies the Parquet file and then does an append or an update, which was quite costly on few of the workflows. On other workflows where you have a very small updates and touches a few files, we didn't have a bigger issues there. But workflows where it was touching a lot of files at the same time had an impact on the write latency. So hence we moved on to merge on reads for those tables and table formats. And eventually we started seeing um, a bit of a data growth. So here, what we mean by that is like we started having clients which are medium-sized clients where we started getting millions of events from them. And this eventually increased our each partition and each table sizes uh, a bit of significantly, not like quite a large significant growth, but yeah, 5x growth is still a significant growth for us. And while we had that, we faced sort of an issues with respect to read latency and also the write latency. But more we were concerned about the read latency. So hence we started having few table services in Hudi enabled. So prior to this, we didn't enable any of the table services. It was just using the defaults with no clustering, no indexing, and no cleaning. But once we saw that there is a data growth, it's just a matter of having a configuration of saying enabling the clustering. So what changes that created, I mean, what impact that created, I have a next slide to explain what clustering gave us in benefit. But yeah, this is just to give an idea of the sort of projection that we went from having the table formats and enabling the table services. Then at some point, what we had was we had some enhancement and some table upgrades that we were planning to do. So one such upgrade was to make use of record level indexes. To just give in context, we were using EMR where the version of the Hudi was 0.13. And as I said, we had a lot of upserts and updates going on at the merge on read and also on the copy on write. And then that's a point in time we saw in 0.14, we have this record level index as a feature, and we want to make use of it. So in order to make use of that, there are two options we had. One is to not to upgrade the EMR, but just upgrade the libraries. But there is another option where EMR also came out upgrading the client libraries within EMR to 0.14.1, which was a good time for us as well. So hence, we experimented with upgrading the EMR cluster. While doing so, we were a little hesitant, like what would happen to this already existing tables, right? So because if I'm not wrong, the table version in 0.13 was table version 5, and 0.14 it was table version 6, which is I'm talking about the Hudi internal table versions. So we were a little hesitant that, okay, what would happen for the existing tables? But to our surprise, to be very honest, that the upgrade happened, I mean, without any config changes on our side. So we just experiment with in the development cluster where when we started using the 0.14.1 client version of library and started writing onto the same table, Hudi itself took care of table upgrades. So which was really good for us. So these are all the small things. Even though it is a very small thing, for a company of our size, it's a very big impact that it creates as we grow as a company. And we are right now in 0.14.1, and but we haven't enabled the record level indexes yet. But this gives us a platform to sort of start using the new features as well in there. Another one is investigating the timeline. Again, this is another underrated feature, I would say, because typically when you start writing into the tables, I mean, if you have multiple writes and multiple table services running at the same time, um, yes, if you don't have an async services, sometimes you, even though if you can manage it by writing into different partitions and to make sure that it doesn't touch the same file, sometimes we face that it messes up the timeline. So in order to investigate what is happening there, the CLI tool, what we did was we just logged into EMR cluster and used the CLI tool provided by the Hudi to investigate a table. So this gives us a very good view and very good admin sort of a tool. It's sort of a power that we have to configure and view what the table is. This is another underrated service which I felt which is really useful for us as well. And OD Streamer, I think it's no surprise. I think it's one of the popular table services and utilities that we have in Hudi. To be honest, we haven't tried extensively using it in many places, but we have used it in few places and it works perfectly fine for us. And as a next phase, what we faced was yes, our company grew as well as then, which also we introduced many new features and bigger clients came into the picture, which evidently gave us sort of millions and billions of events into our platform. So again, this is the same sort of an challenge we had as how we had that 5x data growth, where we had a lot of the read latency was quite high, and we needed to even further optimize the data layout. And this is another place where which is very good for us having Hudi in as our data platform. The reason is, as I showed earlier, we use Cellar data, which is a Star Rocks underneath. So Star Rocks, what it does is basically when you read the Hudi tables, it uses the file system metadata and then prunes all the files. And once it prunes all the files, it uses the footer on the Parquet files to further prune the list of files. So without using sort columns, what happened for us was just using vanilla plain clustering on a specific columns where we use it as part of the predicates in the query. The data was present in all the files, which sort of, I mean, it sort of increase the latency a bit when you have more files written into this particular table. Then once we introduce the sort columns based on those columns on which we do the queries and the predicates lies on, it sort of significantly reduced the read latency. And this is another point which I wanted to share is like having all these features as the timeline goes, we didn't want to make any major changes in our table structure as such. It's just a mere configuration that we changed, which sort of enabled us to grow without any issues or without any problems in our side as well. And file sizing and cleaning comments. Cleaning comments is something which is, I wouldn't say it has created a bigger impact on our side. It's more like to create a sanity in a data platform to sort of reduce the number of files and keep only the latest comments. There are areas where few tables we don't want to have many commits. So we configure only those tables to have only two commits, the latest two commits to store. And file sizing, again, is another powerful feature where few of the tables where if you don't want to store smaller files, you can actually change it to have one particular Parquet file to have, say, up to 500 MB or 1 gig or 2 gig of data set stored in that file. So these configurations are tunable at a table level. So that's the point which I wanted to share with you folks here. And now we are sort of exploring new features. As I said, record level index is one potential feature that we are looking at. And another point to say is like the table services that I mentioned so far, all of this are enabled as an inline table services. So we are also exploring, obviously, to make it as an async table services, which I'll explain in the next steps. Quickly on the practical scenarios and the learnings that we got. So as I said in the previous slide, that clustering is one feature which helped us a lot, even though we are very early stage in our startup, but we saw a huge impact in the kind of performance that we got out of it. There are two dimensions that we got of performance. One is on the storage, another one is on the read performance. On the storage, to just give you a view, we initially started off with having plain Parquet files without Hudi in place. It's just plain Parquet files. So when we started writing into it, we saw there are too many small files being created. As anyone has worked on those Spark and Parquet files, what we have as a configuration is to repartition those data frame, and you provide a number to say, okay, you just repartition by 200 or repartition by 64 files, right? And this sorts of created too many small files when we had very small data sets. As I said earlier, like we grew as a company, we had very small data sets, then we eventually had a huge amount of data sets. But this growth is not adaptable in nature when you have only Parquet file and Spark. Then once we have Hudi in place, what that enabled us is like, as we grew the number of files, I mean, there is a tunable parameter where when you do a clustering, you can say to pack maximum bytes that a particular Parquet file can have. So that helped us a lot to tune adaptively as we grow, as we had more files, more data, then it created more files of same sizes. So that's what we saw here is like a big increase in the storage reduction. So somewhere around 6x we got in few tables and more on few other tables as well. But the idea is to enable from not having a clustering, and with clustering, we just have one config in Hudi. So we just enable Hudi.clustering.inline to be true. And then it just came with all the defaults being the same. We didn't change any of the configs. Just having clustering inline helped us a lot to reduce it. And also to point out why this has an impact is if you look at from the query engine perspective, as I said earlier, the architecture is in a such a way it goes to the file system, then it fetches all those Parquet files and then reads its footer to find which files to prune. If you have lesser files, you have lesser files to sort of search, and it sort of increase the read as well. So that's what showed in the next one in the bottom is not only enabling clustering and enabling sorting by few columns, which is used as part of the query predicates, sort of gave us a minimum of 2x. So this example that I've shown here is with Hudi copy on write and using star rocks. Without clustering, it sort of took around 200 milliseconds for us to query a table with same query, same predicates. But once we enable clustering with ordering on those columns where the predicates is applied on, it sort of reduced quite a lot, like the 2x improvements that we saw. And again, this is a sort of a table that we had, which is 40 million rows in it. But offline, we did analysis on bigger tables as well, because this clustering ordering, we haven't enabled in all the tables at this point in time. But we just did a sort of testing on few tables, and we are confident that this helps us a lot in enabling in the other tables as well. And again, on the config side, it's the same config as before. And additionally, there is another config where we say we sort the columns by column 1 and column 2. So those are the predicate columns, basically. If you provide it, and then Hudi will automatically cluster those files and create those Parquet files accordingly. Cool. Quickly on the challenges and next steps. So one of the challenges that we saw during this journey was enabling the column statistics. So what we found was, as I said earlier, before going into record level indexes, since we had point 13, we thought of using the column level statistics to prune the files and make the read queries much faster. One challenge what we had was it works perfectly fine for tables where you have a lesser columns, but by default, column statistics enables for all the columns in the Hudi tables. So there are some tables we have, like the number of columns are quite high. There is a large number of columns that we have. So those columns, for those tables, when we enable column statistics, it sort of slow down the write operation. Yeah, the caveat or the workaround for this is basically having an async table services, which is one way to tackle this problem. Uh, but um, but this is still a challenge that we faced on our side. But eventually, since we are, as a next step I mentioned, we are moving to have record level indexes. We are not more focused on having the column statistic at this point in time. But eventually, we might have record level index and the column statistics to even further prune it. That is still TBD for us. Another challenge is the partition evolution. I think this is a known challenge in Hudi. It's not a surprise, but just to point out that as a design choices, we have to be very conscious in specifying the partition, the list of columns to use as a partition in a table, because once we define it, then it's I wouldn't say it's impossible to change it, but it's a little bit challenging for us to change it, and there is a bit of an amount of work that we have to do. And on the next steps, as I said earlier, record level index is obvious choice for us because we are started to receive records which has a lot of upserts and updates as an operation. And we did offline analysis, and record level indexes is quite fast in finding the files where the record lies. Which is a significant improvement. I'm confident that we will get out of it. And another one is the Apache Xtable adoption. So this one, I think for people who have not heard about this, so this is sort of an framework built by obviously OneHouse and Hudi community to have an interoperability between the table formats. To just give an example where we might use this is, as I said earlier, Hudi is very good in having all these operations, but some cons that we have, like partition evolution and a few other areas that where, if say we might not find Hudi is a good fit, we might go out and then use the other table formats. The impact that Apache Xtable would create for us as an organization is, as I shown earlier, like we have a query engine which reads directly from the Lakehouse format. Having the Apache Xtable gives us a way to standardize that. So what I mean by that is we always can create tables only target as an Hudi tables, so that query engine reads on the Hudi tables, whereas the write format can be anything depending on the use cases that we have. So if say, for example, I use iceberg tables on the ingestion side and like on the bronze layer, and then I use Hudi on the gold layer, the query engine can read both, but to standardize from the reading purposes, where I can convert the iceberg into an Hudi table as well, so that it's all read as an Hudi table rather than me creating different catalogs for different table formats. So this sort of becomes a game changer for us when it comes to querying and also the usability of the data platform. And the third item mentioned here is Star Rocks to utilize the record level index. This is another initiative we are proceeding right now in enabling Star Rocks to make use of record level indexes in Hudi. To just give an context, even though I enable record level indexes or any indexes in that sense, the respective query engines should honor that, in the sense like it should sort of have the implementation on their side to read the statistics from the Hudi tables. So what we found was StarRogs currently doesn't have a way to read this record level indexes, even though you create as an Hudi indexing columns. It just uses the file index right now. But we are in talks with the StarRogs community folks as well as Hudi, with the Hudi help as well, to implement this on the StarRogs side. Then once we enable record level indexes, we would get a benefit end to end. And lastly, on the async table services, I think this is another sort of I would say, a bigger benefit using Hudi. It's like right now we have an inline services, but right from the beginning, they were thinking about building this as a platform features where you have an async way of managing the tables. Because primary objective of the pipeline is to basically write the gold standard tables and offload the management of the table as an async operation. So it becomes a very pivotal moment for us where when we have this write operation, it takes a longer time. If it is inline writes, and if you don't have any option to make it as a background, we have to write any bespoke way of doing it. But whereas as a Hudi community, there are a few utilities we have, like say Hudi indexer, Hudi compactor, and Hudi clustering utilities, which helps us a lot to do it without any code implementation on our side. So, which is again another underrated service which I wanted to point out. And last but not the least, what I wanted to provide as in context is like the way we saw Hudi as a, we didn't see Hudi as a table format. Rather, it is more like an, they had a lot of platform features which sort of helped us to take a decision to go ahead with Hudi compared to their competitors. Because providing a table layout or a file layout is one problem, obviously, like, but the other, they where they were one step ahead was they sort of gave the platform features like a table services and CLI and other utilities around this format, which helped us to easily maintain the ecosystem in our data platform as well. So those are the big learnings and big advantages that we had using Hudi in our data platform. Yep. So that's it. So I had sort of given a very big understanding of what Hudi and how we use that Hudi in our ecosystem. Feel free to ask any questions you guys have, irrespective of any about us as Metica, or even how we use Hudi in our data platform, or anything of that sort around it. Thank you, everyone.
Thank you so much, Subash. This was a really nice presentation, and I actually made a couple of notes myself as well. Because like there are so many goodies, like and specifically like when you talked about this kind of hidden capabilities that as a platform comes together with Hoodie. I think that is super interesting to know and see it being implemented because people with Hoodie they normally talk about indexes and concurrency control and how it's really good for like low latency workload, but things like Hoodie CLI or like Hoodie streamer, these things get less of a mention, which I think personally is a really good. It comes together as a platform, right? That's kind of
Yeah.
separates from other lakehouse platforms as well. So that's really good to hear. Um, we can take a look at the questions that I saw were in LinkedIn. I think a couple of them you already have answered it and tackled it in some way because they were asked before, but you already had some slide. Um,
Mm.
just say Somil asked, like, are you using Delta Streamer? So that's what he's streamer now. If so, how do you schedule it? Like whether it's Airflow, Lambda, a lot of questions around scheduling in general. How are you scheduling these jobs? Are you using, this kind of like scheduling methods? Can you share any kind of like techniques that you have used for scheduling? Yeah.
Yeah, exactly. I think that's a good question because right now we use Airflow as because that's a standard. It's a much easier for us to use right now. But at the same time, we are also exploring other schedulers to schedule these kinds of jobs. Because what we have seen is like the jobs, the OD CLI commands, it's just like a Spark submit. You just run it, so it works very well with as an EMR step in our use case.
Right. Right. So it's primarily Airflow then, and that's how it's all getting scheduled, everything. Yeah.
Yeah.
Cool. I think there are a lot of comments in general that they are they're good to see like RLI being in discussion. So one thing that I kind of also saw, and I think I'll just highlight it here, it's that the functional index is right, which is available from 1.0 beta 2. I don't know if you're aware of, but that also brings us like similar like hidden partitioning capabilities that you kind of mentioned. So now we can like not have to worry about. So we can have an index on this particular like column and we can prune the data based on a function on that particular column, right? So we don't have to worry about like things like not being able to evolve this partition based on that. So I think that's a good change, and that's I think something I would super encourage. I can share the RFC for you to take a look and for the community to take a look as well. I'll just put it over here.
Yeah, sure. I think that is really, really interesting. And also, there are secondary indexes which is present in 1.0 as
Exactly.
well.
Yeah, that's what I'm talking
So,
about. The functional index basically has secondary as one of the things.
Exactly.
And that's a really good like synergy in terms of like how we're talking about other formats being able to like evolve partition without having to change, make a lot of change or rewrites and stuff, right? So I think that is
Exactly. Yeah.
interesting. Yeah, yeah. um, One question that I have is, do you guys have any multi-writer scenarios in your environment?
Yes, we do. We do have that at this point in time. So that's where we have this locking enabled using the DynamoDB. So right now we are
Okay,
just in the experimental phase to use that.
I see. I see. Cool. All right. One question that I wanted to ask you personally, and we can like it's not a question. It's more of like
Hmm.
a kind of perspective. Is that um, Hudi as a platform and as a table format, it enables you a lot of controls in terms of those knobs that you can tune. You also rightfully mentioned about a lot of easy changes that you were able to make without having to like go through a major kind of upheaval, right? Changing
Hmm.
things here and around, and that's what we usually want, right? It's like usually like,
Yeah.
okay, if you're thinking of a migration, it's a big game. It's a like tough like investment in terms of like everything, engineering efforts and whatnot. So I think the ability to do that was like really good to hear from you. But what do you think in general, like with the perspective of like this different knobs that you get from Hoodie? Have they been beneficial? Do you think this capability to like control more of this particular platform is beneficial?
Yeah, I think that's a very good point because, as I said briefly during the presentation, also I mean, we as an engineers we love to have more control over
Right,
the data platform and the sort of configuration that we can do to optimize. Right.
right,
The
right,
other table formats, what we found was it is more meant for users like an maybe to use it quickly rather than doing an optimization. Right. But
right,
whereas Udi gives us a benefit to optimize each of the table services. If you look at it, indexing, you have plethora of configurations.
right,
Clustering, you have a lot of configurations. So that one, it gives us obviously confidence that yes, we can go ahead and use it as a preliminary one, and then we can, as the features and as the use cases advances, we can have advanced features enabled on those areas. So for me, it's a really big game changing and also a decent factor for us to use Hudi, to be very honest.
right, right. Okay, awesome. Yeah, that's great to hear actually. Yeah, because it's always interesting to see like this, these different controls that we talk about, and how people are using it. And yeah, personally, I also benefited in the past with like different like other formats. So I think it's important that we have this kind of capabilities, and the fact that comes by default is really like, yeah, interesting. Yeah,
Yeah, and also to just say to kudos to the community as well. The documentation is very good, and the RFCs being maintained gave me a good understanding of how it's been implemented. So that's
right.
another piece which sort of gave us in-depth knowledge of how this is being used, and we see it in practical scenarios also once we enable it.
Perfect. Yeah, thank you so much. I mean, like, this is like a really good feedback as well. Like, specifically with that RFCs, like, I love reading those RFCs like myself.
Yeah,
It's so detailed, and you really get a good idea and sense of what is being implemented and what are the kind of like caveats and whatnot. So yeah, and also the documentation. We are really, working towards like improvising documentation. So even for the community, any feedback that you guys have, like, it would be really good, like, to share with us, and what you want to see, what you not, maybe some real, kind of real examples, like some failure scenarios, error debugs, like those are the kind of things that we want to like really put it out there.
yeah,
Um, yeah, one question I had from Poe is, besides Starrock, what other query engines do you intend to use in the future? Is there any
right.
plan?
Yeah, I think Starbucks works very well for us on the BI and reporting use cases. But the UDI RS that you mentioned, Dipankar, which is
Right.
another area which is really, really interesting for us to do in ad hoc analysis,
Okay.
because we don't want to use Starbucks sort of an query engine to do a very uh, ad hoc bespoke analysis on a
Yeah.
subset of data sets. So we used Daft a bit, and we used Starrocks a bit, and also yeah, I think Daft was the one which is prominently used. But from
Okay.
the query engine perspective, we are not planning to use sort of Trino or any equivalent which is of that size of Starrocks at this point in time, because
Got it.
Starrocks gives us a good benefit at this point in for the subsequent latencies.
Got it. And the way you mentioned about this data frame libraries with DAFT specifically, like, are you like using that specifically for like data science and kind of ML use cases, or is it?
That's right. So, because mostly when we go into this data frame ecosystem or a single node stack or whatever we
Right.
call it, right? So these sorts of tools helps us a lot to do analysis quickly rather than going with this bigger query engines and querying it. We
Right.
use it more for a production sort of an use cases. We use startups, whereas ad hoc analysis and ML use cases for training it and using data frame structures. We use these
Perfect.
DAFT and UDRs is one which we'll explore. We haven't used it
Yeah,
yet.
absolutely. I think yeah, for sure. And I already like it has integrations with like query engine like Data Fusion. So that's another
Yeah,
RAS-based query engine. A really good momentum over there as well. And of course, like we have had like good integration with Daft. Like you can use Hoodie table directly, read the table directly with like Daft. But also we are going to like see a bit of change in the Hoodie R is being used in the Daft code now because at that point of time we didn't have this library. So I think
got
it's
it.
all coming together in a way and like really evolving into this different ecosystem with like Daft, Polars, and the kind of Pythonic world, if you may.
Yeah,
Yeah, perfect. I don't see anything else. I'll just give a minute or so, just in case someone has something, any comments, any suggestions. But overall, really good presentation, Subash. Like I really like the way the kind of the problems were kind of like started with. The evolution journey itself is super interesting, right? You are a startup, and you need something versatile, I guess, down the line, requiring less
yeah,
changes. And I think the evolution has been pretty much in that line. So thank you so much for presenting with us today.
yeah. Sure.
Um, yeah, I'm just quickly going over LinkedIn and seeing like if there is anything else.
Mhm.
Hmm. All right, so really, yeah, good comments around like presentation, of course, like yeah, very informative. I think that is all. Yeah, I think this was really great. And it's good to see like the use cases of Hudi being used across organizations. So thank you so much, Subhas. For people who were not able to join, we'll have this presentation available as a YouTube recording later in the week, and feel free to take a look from there. And thank you so much once again, Subhas, for being
Yeah,
with us
thanks
today
a
and
lot.
joining it.
Thanks a lot for this opportunity as well. Thank you, guys.
Bye.
Bye.